we introduce AdaManip, Adaptive Articulated Object Manipulation Environments, and Policy Learning. Among the various categories of objects in our daily life, articulated objects is highly significant as it is common in our surroundings. Previous works for articulated objects have primarily focused on simple manipulation mechanisms where the complete manipulation process can be inferred from the object's appearance. However, composed of multiple parts connected by joints, articulated objects are endowed with diverse functional mechanisms through complex relative motions. Due to the unobservable internal structure, such as the state of a lock or joint angle constraints, a static policy trained with optimal trajectories as demonstrations leads to a bimodal distribution based on visual observation alone. If the robot samples the unlocked trajectory and fails to open the locked door, it will be out of distribution. Therefore, we incorporate the adaptive demonstration, which includes recovery from failed door opening for adaptive manipulation policy training. Thanks to the adaptive demonstration, the policy learns to first pull the door to check the lock state and updates the policy distribution accordingly based on the feedback. Previous datasets and simulation environments for articulated objects often lack diversity and realistic manipulation mechanisms. To address this issue, we developed a new environment to explore complex mechanisms in articulated object manipulation better and learn adaptive manipulation policies. Based on ICLR, this environment simulates these mechanisms and includes 9 categories of objects with 5 types of adaptive mechanisms. Here we show these mechanisms on different objects. For adaptive manipulation policy training, we first propose a method for adaptive demonstration collection. Here is an example. Since the lock state of a microwave is uncertain, we force the robot to first pull the door to check if it is locked, followed by 2 kinds of trajectories accordingly. We employ a diffusion-based 3D adaptive manipulation policy for articulated object with complex mechanisms. Conditioning on the history of 3D visual features, proprioceptions and actions, the policy denoises Gaussian noise into the trajectory distribution. In the beginning, the policy captures the bimodal distribution and the demonstration based on initial observation. Then the policy distribution adaptively shifts to a unimodal distribution conditioning on the observed lock state. We conduct experiments in the category level covering all the 9 object categories. The qualitative and quantitative results demonstrates the superiority of our proposed method and its components in manipulating articulated objects with different mechanisms. We compare our method against several state-of-the-art algorithms, including affordance-based manipulation and imitation learning. We also do the analysis for repeated adaptive demonstration. The performance decreases when the number of repeated adaptive trials increases from 1, validating the superiority of our design. To validate the generalizability of our adaptive diffusion policy to real-world scenarios, we conduct experiments on various real-world objects like pressure cooker, microwave, bottle, and safe. The results in the slide demonstrate that our adaptive policy can be effectively applied to real-world scenarios.